How much do we know about space? To us, people of the 21st century, it seems like we know a lot. Not a single corner of the universe can escape our attention, and we think that we already understand how the world works. But is that really the case? Sometimes the universe gives us a wake-up call, presenting us with new mysteries. That's exactly what happened in the fall of the crazy year that just passed, when scientists discovered a planet whose very existence calls into question the familiar picture of what we know about the evolution and life of cosmic objects. As you know, the starry sky never goes unnoticed by people on Earth, armed with satellites and telescopes. One of them is Transiting Exoplanet Survey Satellite, a National Aeronautics and Space Administration satellite aimed at searching for exoplanets and planetary systems outside the solar system. The goals of this program, carried out by an international group of astronomers, are very ambitious. First and foremost, it is the search for exoplanets similar to Earth, which in the future could become a potential home for humanity. The program has already discovered many types of planets that are unlike those found in our small solar system. But in September 2020, scientists saw something completely unique. And it's not just about an exoplanet, but an entire mini-planetary system that in principle shouldn't even exist. So what is it like when astronomers observed the NASATESS transit in the constellation Draco, about 80 light years away from us? Something unusual caught their attention. It was a huge object located almost right next to a dim white dwarf, orbiting it at tremendous speed. To determine whether it was a star or a planet, scientists studied the object's infrared radiation using the Spitzer Space Telescope. The results shocked the scientists. Not only did the object turn out to be a giant planet, which was named White Dwarf 1856b, but scientists also discovered that it was cold, not hot at all. What should we expect from a planet that has come so close to a star? The upper temperature limit of White Dwarf 1856 is only 17 degrees Celsius, which is comparable to the temperature on Earth. Just imagine a planet almost pressed right up against a half-dead star has a cool, comfortable temperature for humans. Moreover, the size of White Dwarf 1856b is comparable to that of Jupiter, and it is 7 times larger than its fading star. The White Dwarf itself is quite small. It's only 40% larger than Earth. To imagine what this pair looks like, just picture Earth orbiting the Moon. Although in proportion the White Dwarf is even smaller compared to its planet. You have to admit, it's an amazing sight. But that's not even the strangest part. White Dwarf 1856. B is so close to its star that a year there lasts only 34 Earth hours. That's more than 60 times faster than the time it takes Mercury to orbit the Sun. How can a planet be so close to a star and have such a low temperature? Why hasn't it been destroyed by radioactive radiation yet? That question would be fair if we were talking about an ordinary star like our Sun. But with white dwarfs, the situation is completely different. What are they like? White dwarfs are one of the final evolutionary paths for those stars whose mass is not enough to become neutron stars. For this, a star needs to have a mass of at least 10 solar masses. Smaller stars have only one path. In the process of constant thermonuclear nucleosynthesis reactions, which are the main source of energy for stars, sooner or later there comes a stage when the star expands, turning into a red giant. Its temperature decreases during this process. In the process of further fusion reactions, the red giant cools down even more, and at some point, the star sheds its outer shell, which consists of gas, losing about 80% of its mass in the process. And it leaves behind a plasma core with enormous mass and very strong gravity, which becomes a white dwarf. It, in turn, also goes through its own path, gradually cooling down and losing brightness. Does this mean that white dwarfs are cold enough for planets to coexist peacefully at such a short distance next to them? Not at all. A year before the discovery of white dwarf 1856, B researchers working with the European Southern Observatory Telescope discovered a hot white dwarf surrounded by an accretion gas disk and a partially destroyed planet not far from the star. By analyzing the radiation from the dwarf, scientists found unusual elements in its spectrum that literally formed a disk around the star. The conclusion was obvious and relentless. The particles of hydrogen, oxygen, and sulfur swirling around the white dwarf are the evaporation of a Neptune-like planet that is too close to its neighbor and is being destroyed. Under the influence of gravity and powerful enough radioactive radiation, the white dwarf literally evaporates and destroys the planet, pulling the particles in with its strong gravitational field. And unfortunately, the same unenviable fate awaits the planets of the solar system in the very distant future. So, white dwarf 1856b is not the first planet orbiting a white dwarf. It's not unique. Actually, no. If the planet we talked about earlier is almost destroyed by its star, white dwarf 1856, B is doing just fine and isn't about to break apart or evaporate. This is the first planet of its kind discovered by scientists. It would seem obvious the white dwarf destroying its companion is just too hot. And its neighbor, white dwarf 1856b, which scientists estimate to be at least 10 billion years old, is old and cold enough. And it can't not only harm the giant planet, which despite its size is actually much lighter than it, but it also can't even heat it up enough. So what then is the contradiction and the mystery for scientists? The question is this: how did white dwarf 1856b manage to survive the transformation of a red giant into a white dwarf, which is always accompanied by a powerful explosion and a release of gas? Usually when a star sheds its outer layers, it releases energy so powerful that all nearby objects are destroyed, and their debris can then be pulled in by the strong gravitational field of the exposed stellar core. White dwarf 1856. B somehow got very close to its white dwarf and managed to stay intact, said Andrew Vanderberg, associate professor of astronomy at the University of Wisconsin, Madison. The process of creating white dwarfs destroys nearby planets, and anything that later comes too close is usually torn apart by the star's immense gravity. We still have many questions about how white dwarf 1856b ended up in its current position and survived. But if white dwarf 1856b managed to survive, does that mean Earth also has a chance not to be torn apart when our sun undergoes the same grim transformation in many billions of years? Maybe it all depends on the mass of the planet. If Earth were the size of Jupiter, it could survive. Unfortunately, no. Unfortunately, the existence of white dwarf 1856b does not prove at all that a planet can survive the explosion of a red giant. Moreover, even if it somehow wasn't destroyed, white dwarf 1856b would face the same fate as the planet we talked about earlier. It would be scorched and gradually destroyed. A young and hot white dwarf. This means only one thing. At the moment of the red giant's explosion, white dwarf 1856b must have been at least 50 times farther from its current distance to the star, and only much later migrated toward the white dwarf. How did that happen? Obviously, despite its powerful gravity, the stellar core wouldn't have been able to pull such a distant and massive object toward itself. The hypotheses that scientists propose on this matter are numerous and diverse. The most likely scenario involves several other Jupiter-sized bodies close to the original orbit of white dwarf 1856, B noted Julietta Becker, a 51 Pegasi B Fellow in Planetary Science at Caltech, the California Institute of Technology in Pasadena. The gravity of such large objects could easily create the instability needed to push the planet inward. But for now, we still have more theories than data. Unfortunately, for now, we can only guess how White Dwarf 1856b ended up in its current position. Did it survive the explosion of the red giant, manage to withstand the radiation of a young plasma star, or did it take a very long and mysterious journey, eventually ending up in orbit around the White Dwarf? Scientists plan to obtain new data regarding this mystery with the help of the future James Webb Space Telescope. For now, all we can do is wait for news and reflect on how little we still know about the structure of this world. In 1950, Ray Bradbury's novel The Martian Chronicles was published, but could the writer have imagined that its title would take on a meaning that is not so fantastical? Just 70 years later, millions of people are following news from Mars. And today I have some hot news for you. The temperature is -90 straight from the acidalian Martian Sea. So, as we already know, back on February 18th, 2021, the rover Perseverance landed. Another source of pride for scientists was the discovery of a real stone field. Of course, now Earthlings can already see a panoramic photo of Martian rocks. It's tough for the hard worker to operate in such conditions, but don't worry. Perseverance's wheels are built for even harsher environments. They give the rover a bulldog-like grip on the rugged Martian landscape thanks to individual motors for each wheel, titanium spokes and tubes, and a total of 48 tread cleats. Naturally, rocks up to 40 centimeters high are no problem for it, and that's not all. That means a 360-degree turn is guaranteed for the rover, which prevents it from slipping. I wish Traxxas would use that technology. It's incredible that the device's scientists and engineers are geniuses. But why do these talented people lose so many nerve cells every day? It's because every gifted person worries about their creation. Every step, every setback is an emotional experience for them. I really hope that my channel is watched by those who are truly passionate about this topic. And he's interested in the mysteries not only of his home planet, but of the entire universe. Do you believe in the words of Vanga? They will find life in space, and it will become clear how life appeared on Earth. After all, by exploring space, we learn more about ourselves and about our home called Earth. But let's get back to the hero of our report, the Mars rover Perseverance, or more precisely, to its protege, the drone Ingenuity. It was the one that made its creators quite nervous. The drone's first flight was scheduled for April 8, postponed to the 11th, but ultimately didn't occur. In general, for everyone following the Martian Chronicles, the press service of the American Space Agency, National Aeronautics and Space Administration announced that the flight would take place no earlier than April 14th. So, what happened? Recently, Perseverance sent a great selfie with the drone back to Earth, and it was all because of the software, which malfunctioned. Unfortunately, the coverage of unsecured Wi-Fi on Mars still leaves much to be desired, and the update took a lot of time. I think we can forgive the specialists for such an error, since Mars's thin atmosphere is only about 1% of Earth's atmosphere. Anyone could get confused in such conditions. Fortunately, the software has already been updated, and Ingenuity's direction of movement is now known, which is to be expected since the little guy, weighing only 1.8 kilograms, is equipped with two powerful coaxial rotors with a diameter of 1.2 meters, and they spin at an incredible speed of 2,500 revolutions per minute. By the way, that's a fact. Before the Perseverance rover landed on the surface of the red planet, another Mars rover named Curiosity celebrated a kind of anniversary. This old fellow, which is actually a fully autonomous chemical laboratory, arrived on Mars on August 6, 2012. During its mission, it has collected a real archive of Martian landscapes and still regularly sends Martian weather forecasts back to Earth. We hope that Perseverance will repeat the success of its colleague and work just as efficiently. Although, that's not a fact. Recently, footage of the Red Rebel's surface went viral online. Hundreds of thousands discussed the Mars rover images sent to its creators. A rainbow is clearly visible in them. But can a rainbow really shimmer with its colors on Mars? Of course not. The National Aeronautics and Space Administration explained the unusual photo from Mars. A rainbow appears because of light reflected from water droplets. However, there isn't enough water here for condensation, and it's also too cold for it to be liquid. This arc is a lens flare. But then how can we explain these mysterious traces on the Martian surface? I'm waiting for your suggestions in the comments. In fact, not so long ago, Perseverance delighted its creators with the success of a unique experiment, a breakthrough for all of humanity. As you know, the main task of the rover is to collect Martian soil and search for traces of biological life. But the tireless worker managed to extract the first oxygen from the atmosphere of the red planet. According to the National Aeronautics and Space Administration, such an incredible success became possible thanks to a very compact device called the Mars Oxygen In Situ Resource Utilization Experiment, or simply Mars Oxygen In Situ Resource Utilization Experiment. With its help, 5.4 grams of oxygen were extracted. This amount should be enough to support an astronaut for about 10 minutes. The device spent 2 hours preparing for the experiment, but only 1 hour extracting oxygen. But does it really matter when science fiction becomes reality? Maybe it's not for nothing that the famous songwriter Yevgeny Dolmatovsky promised us that apple trees would bloom on Mars. This is just the first step, but it's very promising. Perhaps the time when people will be able to enjoy blue Martian sunsets and sunrises is not far off. Because of the thin atmosphere, sunrises and sunsets on this planet are drastically different from Earth's. By the way, oxygen on Mars is needed not only for astronauts to breathe, but also for rocket fuel. So it looks like a one-way trip to the red planet is no longer necessary. After all, delivering 50 tons of oxygen and 14 tons of rocket fuel for a round trip for 4 astronauts would be an impossible task for the specialists. Now, producing fuel right on site doesn't seem so fantastic anymore, thanks to the very promising, innovative Mars Oxygen In Situ Resource Utilization Experiment technology. And the principle of its operation is separating oxygen atoms from carbon dioxide molecules. Fortunately, there's plenty of it on Mars, as much as 96%. Is there a boundary that we as humanity will never cross? Are there places we'll never reach no matter how hard we try? As it turns out, there are. Even with incredible science fiction methods, we found ourselves trapped in a vast pocket of the universe and the matter within it. So how many universes are there really? And how far will humanity be able to venture into its depths? When we look at the night sky, it seems like we see stars being born and dying again in a cycle that appears endless. However, that's not the case. Imagine the Milky Way has a diameter of up to 200,000 light years and contains between 90 and 450 billion stars. Answer the question, how many stars are born here in 1 year? Millions? Thousands? But actually only about 3. Are you surprised? Only 3 stars a year. 96% of all the stars that have ever existed in the universe have already been born. We are now in the twilight of star formation. Now we are living at the dawn of the end of the universe as we know it. Moreover, the formation of new stars will continue to slow down, but that's not all. As it turns out, the universe is running away from us. Also, the Milky Way is not alone. Together with Andromeda and more than 45 dwarf galaxies, they form the Local Group, a region about 9 million light years in diameter. You can consider this our galactic neighborhood. From here, more than 100 galaxy groups like the Local Group make up the Laniakea supercluster. which itself is just one of a vast number of superclusters. In total, at this point, there are about more than 2 trillion galaxies that make up the universe as we see it right now. Unfortunately, even if we could travel at the speed of light, about 93% of the galaxies we see right now are already impossible to study. Why are all these galaxies already out of reach? This is because of how galaxies come into existence from the Big Bang. Simply put, about 10 to the minus 36 seconds after the Big Bang. The young universe was a very small bubble of energy. However, it wasn't completely uniform. Some parts were a bit denser than others, which had serious consequences in the future. In a process called cosmic inflation, the observable universe expanded rapidly from the size of a small ball to trillions of kilometers in a trillionth of a second. This happened so quickly that all those tiny differences in density were stretched from subatomic sizes to unimaginable galactic distances. And that's the only reason the visible universe is made up of regions that are more and less dense. The pockets of the universe are filled with a bit more matter than the space that surrounds them. Ultimately, even this brief yet intense inflation ended. Gravitational forces tried to gather and unite everything. The local group is our home in the vast universe. But on larger scales, beyond the compressed pockets, the expansion of space did not stop. This means that our local group is surrounded by matter, but none of these structures and galaxies are gravitationally bound to us. The more the universe expands, the greater the distances become between us and other centers of gravity. But what's even worse is that the universe is accelerating its expansion. So far, we don't understand why this is happening. That's why we come up with various hypotheses about the existence of dark energy. You can imagine it as some kind of invisible effect that helps accelerate the expansion of the universe. So all we need to know right now is that the universe is expanding faster and faster. This expansion means that there is a cosmological horizon around us. Everything beyond its boundaries starts moving away from us at a speed faster than the speed of light. From this, it follows that everything that happens beyond the horizon is irretrievably inaccessible and is unlikely to ever become accessible. We won't be able to interact with it. In a way, it's similar to the event horizon of a black hole. 93% of the galaxies we observe today have already crossed it and are lost to us forever. But wait a second, if there's no way for us to interact with them, why are we still able to observe them? But here we can thank light. And although the speed of light is the fastest way we know to travel through the universe, it still takes a certain amount of time to cover the distance from one point to another. Every second, light reaches us from trillions of galaxies that have crossed the horizon. After all, when their light was emitted, they were closer to us. We study their past and understand their position at that time. Thus, the observable universe is literally larger than the universe we can interact with. The universe is telling us an amazing story, revealing phenomena that are now forever out of reach. We can only observe them over an extended period of time as their light reaches our telescopes. The universe observed in real time is still expanding. Realizing this is truly breathtaking. Eventually, all regions outside the local group will move beyond our cosmological horizon. When that happens, their light won't reach us anymore. And from this perspective, they'll vanish into darkness. Every moment of your existence, 50,000 stars cross the horizon and disappear from us. Since you started watching this video, about 20 million stars have forever gone beyond our reach. I see. But if 93% of the observable universe is beyond the cosmic horizon and gone forever, there still must be 7% left that should be within our reach. That's, for a moment, all the galaxy clusters that are less than 19 billion light years away. At the moment, they're still moving away, but very slowly, so physically, we can try to reach them, although the chances are dropping with every second. Anything that's more than 6 million light years away is moving away from us. The closest galaxy groups are moving away slowest, creating a temporary chance to reach them. Even at the speed of light, the journey to the Mophea group and the nearest galaxy cluster outside the local group would take us 12 million years. Suppose some incredibly advanced civilization tried to do this. Its inevitable sphere of influence could expand to hundreds or thousands of galaxies. We can safely assume that humans won't make this journey, at least not with technologies that are even remotely at the cutting edge of scientific thought. For humanity, the local group is the largest structure we will ever be a part of. Even traveling between this group's stars would be a colossal achievement. As dark energy drives the universe apart, the local group will grow increasingly tightly bound. All its galaxies, both large and small, will merge together, forming a single giant elliptical galaxy with the non-trivial name Milky Andromeda or Milk Meta. This process may even disrupt huge gas clouds and temporarily restart star formation. And this single light will be highly desirable, because at some point the galaxies beyond Milk Meta will be so far away that they will become too small to be seen. Once this happens, no information beyond the local group will be visible to us anymore. The universe will disappear from the field of visible observation. A being born in the distant future in Milk Meta will think that the universe consists only of its own galaxy. When they look far into empty space, they will see only even more emptiness and darkness. They won't see the cosmic background radiation and won't be able to learn about the Big Bang. They might not have the opportunity to learn what we know today, the nature of the expanding universe when it began and how it will end. They might think that the universe is static and has always been that way. Maleko Meta will be an island in the darkness, growing blacker and darker with its trillions of stars. The local group is certainly a large enough playground to entertain its inhabitants for some time. After all, we still don't fully understand how to leave our solar system. And if not us, then our descendants still have tens of billions of years left to explore our galaxy in more detail. And we're actually very lucky to exist at this perfect moment in time, to see not only our future, but also our most distant past, just by looking up at the night sky. Even if the local group is isolated, it's still our home. The final frontier of humanity, perhaps contrary to the dreams of science fiction writers, is closing in around our home. And the Hubble channel will do everything it can to make sure as many people as possible learn about our cosmic homeland. But we can't do it without your support. You can not only watch, but also share our video and click the bell so you don't miss a new episode.